Hello everyone and welcome back to the channel. I'm actually very excited to be working on what's inside this case here. We're going to attempt to restore to service a wonderful piece of test equipment. Now, I am very familiar with the Ameritec personal transmission test set, model number AM-48. As a matter of fact, I used this over a 20-year career maintaining switching systems for telecommunications and radio end items, radio broadcasting type environments. And so I'm pretty familiar with what this guy does. And actually, this is a portable transmission test set. It's akin to like the HP 4935 Alpha transmission test set that I keep on my shelf over there. I'll throw up a picture. But this one, being more portable, made it easier to use to troubleshoot and take measurements. And typically we had two of them opposing ends for what we had to measure with. As a matter of fact, the Ameritec itself, I believe this company went under several years ago, and within the community I worked in, these became very scarce. They broke, they went back to the depot, and in all honesty, the depot never got a contract to get them under repair, and so they were pretty scarce out in the field. Although you can find them relatively cheap on eBay if they actually work, for around $400 to $1,200. More reputable suppliers listing them as refurbished units. You're looking close to $2,000, if not over $2,500 for just one of these. Now, this AM-48 came to me via somebody who acquired it from a federal agency, either at auction or something, and then it was given to another individual who gave it to me because it does not work. What he mentioned is that the batteries were all corroded, and yeah, inside the terminals here we do have some corrosion on our batteries, especially on this side right here, on these basically springs, what the AA batteries would sit in. So he took the batteries out, and he took the power supply, and he hooked the power supply into the bottom of the unit, and it powered on for a second and would turn back off. He could not get it to stay on. So we're going to try to remedy that and get this AM-48 back in operation. Now, to give you a little bit of history on our AM-48 here, and most of this you can just gather from online resources. It was considered a compact, user-friendly, yet powerful handheld analog transmission test set. Weighed around 2 pounds, easily transportable in its tool case, essentially, or toolkit. Operated on 4 AA batteries, as I previously mentioned, or an AC power supply. Primarily this was used for 2 or 4 wire, as you see down here, type transmission test set testing. So analog type equipment. Could be terminated or bridged 600 or 900 ohms, depending upon your telecommunications equipment. Actually, that's switched down here. Okay. Usually I left it in tone when I used it. But anyways, it provides a variety of measurements in both the 2-wire and 4-wire testing capabilities, such as end-to-end tests of 4-wire data lines, as well as 2 and 4-wire analog communications. Most of the testing was done within the range of 200 hertz to 2 kHz. You can measure your dBm level and determine dB loss, frequency response, noise with tone, signal over noise ratio. Then you also had like 3-level impulse noise, phase and gain jitter, and hits and dropout. So this one actually came with quite a few things. The handy dandy manual. Most of these went missing many years ago in the work centers I was in over the year. A digital copy of the manual. Surprisingly, this one comes with this original calibration certificate, circa, was that August 27, 1997. We can see down here who was verified by, who did it, and the serial number being 3397593, which is located right here on the back. And oddly enough, this was actually very good for like telecommunications type troubleshooting, because you didn't just measure, loss or distortion or any of those measurement type functions, but you can see right here we have a DTMF function, total tone multiple frequency, a keypad. So this device actually, if you look, you got a mic here and a speaker up top. It actually dualed as something that we would call a butt set. So basically, pretend that this is a handheld telephone, and if you hooked into PSTN or plain old telephone system, where the phone would typically go, either 2 or 4 wire communications, you could use this to dial a telephone number and make calls as well. So again, a very nifty device. We have one patch cable here, RJ11 both sides. Let's see, 4-wire. Yeah, we got yellow and black, and the center 2 pins being green and red for our transmit and receive over 4-wire pair. We have the same RJ11 patch cable or test cable, along with gator clips on the other side. These would usually clip onto demarcation blocks if there was not a RJ11 plug on the other end, or puck. Let's see. We've got the power supply here. We'll need to test that. And we got a little external speaker as well, so you could put this into your ear versus having to listen from the speaker up here on top. So really cool, nifty functions. I actually never saw these, nor this certificate, nor this CD manual, nor this other manual anywhere that I worked that actually had these. Like I said, this is a pretty well put together box of equipment and product support type stuff. So without further ado, let's try to get this operational. We'll test the power supply, and if it's good, we'll plug it in to see if we can't get this to stay on. Oh, and one thing I failed to mention, here's where your RJ11 plugs into. Now, a lot of the switching systems I would use this to do alignments on required phono type style plugs, not 3.5 millimeter. They were a different style plug, and we would do transmit level adjustments over a transmit bridge, and receive level adjustments over the record or receive bridge. So you have multiple types of test leads that you would use with this, but if we get this working, I'll just be using the RJ11 to gator clips to run a few tests to determine the accuracy of the signal generator that's in this, as well as the receiver, to make sure that it is measuring things, at least levels, at an appropriate level of whatever I'm sending out. All right, power supply. Power supply is 120 volts AC, either 50 or 60 hertz. It's a 8-watt power supply, outputting 9 volts DC, and max amperage 250 milliamps. So let me get this plugged in my outlet underneath my desk, and we'll take a multimeter to it. Okay, nothing about this is too off the wall. So DC, we got that set to DC. And outer, I believe, is our ground, and center is going to be our positive. Actually, I got that wrong. We're 11.7 volts. So center is ground and outer is positive. Why are we over 9 volts? 11.7, that's quite a bit more over voltage. Could that be the issue? That's the wrong power supply for this unit? 9 volts DC. I'll tell you what. Why don't I use my external power supply and go off the battery terminals despite them being corroded, and we'll see if it powers on that way. If you want to see that corrosion, let me zoom in a tad bit here. Can I zoom in? There we go. Alright, now hopefully that becomes a bit more apparent to you. You can see the corrosion here on these terminals. This side, not too bad. We just have some lead battery acid. That's all that is. So with 4 AA batteries at 1.5 volts, we're looking at 6 volts total for operation. We'll set my power supply to 6 volts and see if we can't get this to turn on. Okay, so I got my tabletop power supply turned on 6 volts, and let's see if this turns on and stays on. Alright, I get a ready indication, and it's running through a self-test and staying under. Let me bump up the voltage just a bit, and that gives us some stability. Yeah, so it's staying on, and that's saying under. What if I monitor send? I'm going to put it on terminated tone, 600 ohm. It's in 4-wire. Okay, yeah. Take it out 4-wire reverse. Let's go over to send, and we'll select 1004 hertz. Ooh, our select button does not seem to be working. That seems to be broke. We're on shift. Okay, so that's something that we're going to have to look into. Let me turn it off, turn it back on. No, she's definitely got some issues. Yeah, it's decided not to turn on. There you go. Now it's on. I'm wondering if this is having an issue with the input power supply. Actually, let me turn it off. We'll zoom in, and I'm going to turn my filters off so that way you can hear exactly what I'm hearing. Okay, forgive me if you have noise in the background, but I'm going to turn this on and hopefully you can pick up the issue. It's drawing about 1.8 amps. And it just won't stay on. Now about 0.2 amps. Let's turn it off again, turn it back on. And we're definitely having an issue here. Okay, well, I had to consult the owner's manual for it, and it basically tells you for the AC power adapter that the orientation of the positive and minus rail on the 2.5 millimeter jack is written on the housing of the AC adapter itself. So I looked in here because I wanted to verify if that's the proper orientation for this 9-volt input, but unfortunately could not find that within the manual. So we're just going to try it out, see if we get anything different. I got static. Oh, screen went out. Yeah, and it's still wigging out on us. Okay, well, I suspect we got more than just a power supply issue. At this point, I think we're going to be taking this apart. Okay, so we got it apart, and well, you can, this is easier for you. You can see the amount of corrosion that's on these metal plates here. This one over here being slightly worse. So that's definitely an issue. Now, I just have the back case off of the back half of the clamshell off the case. We can see we have multiple daughter boards and then the main board down here. And I think I spot the issue just by a visual inspection. I'll show you that to you here in a second. I will need to desolder these wires to get them disconnected from these terminal ports here, or the termination here, and then maybe I can just pop the clips out, get them out. We'll see here in a second. I think that's going to require desoldering. But this is not fully releasing from its parent board. And the way these posts are here, I'm kind of wondering if there is screws or anything hidden underneath here holding in this bottom board per se. But let me show you what I've seen just by turning it on, and I think this failure is primarily just due to battery issues. Can I get my microscope over here? Give me a second. Alright, well, under a microscope things become a little more transparent. You seeing all that right there? And if I was to tilt this up a bit, oh yeah, that's the good stuff. That's the expensive stuff, the blue stuff, not the white stuff. But we got a bit of the white stuff too. I bet those traces are pretty much gone. We got test points and other traces. But this is primarily looking to me that like the battery acid got onto our main PCB and ate away at our circuit board traces, at least creating an intermittent issue. That's why it won't stay power up. So we have a confuser kind of right here, HD63A03R1L. I believe the 1L being the specific package type configuration, you can see that this is square. Similar chips like the HD63 Alpha 03R, the standard one, being a CMOS MPU, are a little more rectangular in shape. So this appears that they had a very specific, it's probably the same device, but just a different form, dimension set. So a very specific package type. Probably could use the 03R if I can get a replacement. I might pull up a data sheet, but hopefully we won't need a replacement. And then over here, this is going to be our octal, I believe. What is this? A 74HC573 logic octal transparent latches. Yeah, so we can see that there would be communication between the CMOS and this device right here for functionality. I'm going to try to clean this up just a tad bit with some isopropyl alcohol, and maybe we can get a multimeter underneath there and just check, to see if we are having, see if we got continuity across these traces you see, especially from whatever point this is going to underneath this IC. These points here, those all look 8 away. This one all the way to that test point there. We might be able to discover some things just by cleaning this up and checking test points. With some of that cleaning out of the way, I kind of want to go back and test it again with the power supply just to see if there's any difference. I don't imagine there will be, but with that corrosion primarily for the most part removed minus the damage we see on the PCB, maybe we get some stability back in how this thing works or operates, and we can possibly determine from there if we have any other issues. Okay, have it plugged in. Let's power it on. And it appears, well, let's cycle, put it back on send. Let's cycle through our transmit settings. No, we're still having some issues. Interesting. Take this back cover off. Let's try this one more time. Yeah, I hear a relay trying to click over in there, but no bueno. Okay, so there's no way around it. We are going to have to take this further apart to try to get this working again. Alright, so breaking down further was not so much of an issue. No hidden screws on the front. Basically, this daughter board that we had here, see this pin header? That was seated into these pins on that daughter board. And so it was just rocking it back and forth to get out. Now, one thing I did notice, and I'll try to get it in the camera shot up here. Maybe you can see that. Notice anything weird about this electrolytic cap? It's awfully corroded on the end. These are 100 microfarad 15 volt electrolytics. We could probably replace them. These polypropylene capacitors are most likely fine. Most likely used because of the type of device it is, requiring, those type of capacitors for noise filtering, etc. But anyways, digressing, these electrolytics will probably end up replacing. That first one doesn't look good. We can pop that one off and test it at some point. All right, so I did have to desolder these two leads here, going to the battery pack over there, and then pry off this insulation here from this point here. But in order to lift this up, these 3 small standoffs had to come out, and so they just unscrewed. And then the same thing, you got pin headers here, you got pins, and just rocking back and forth until the device or this daughter board was released from this main board here. Yeah, a lot of electrolytics, we can test them. It's not a super old device. I wouldn't suspect these to be bad. That one being corroded up there, yeah, we should probably just go ahead and replace it. Again, we'll test them, but I highly suspect that all these are not bad. And then here goes our main board. Now, you do have 4 nuts here, but the nuts, what they're doing is they're just holding the display, our LCD display, to that board. Now, I'm probably going to have to rock this back and forth. I think it's held in by double-sided tape at the bottom, or maybe it's just pressure from our keypad, and trying to keep it in socket here. But this should pop out. It's coming. There it goes. And there we go. Yeah, so just a pin header here, and pin headers here, and those fit into these pins right. Okay, do I have those on camera? Right there. All right, and then our membrane for our keypad. All that looks fine. It's gonna make cleaning up this board a lot easier now that it's removed. But the main thing is figuring out what to do with these traces. And this is going to be some micro soldering, just to say the least. But with them out, I can verify one trace I couldn't really get to. And so I'll just put my multimeter here. It's got a test point there. Test point here. I thought it was suspect, but we got continuity there. So I think this is going to be a trace repair primarily between these two things. We're just going through and really cleaning this up and checking some capacitors, and I believe those two things will get these back in operation. So long as our ICs are good, hopefully. We'll see how it goes. I think we've got this back together good enough, and we've done a few repairs. The one cap that was corroded, now it's still measured within tolerance. I am slightly concerned the style electrolytic I put in there, because I believe this to be a highly, very, very small tolerance cap. Probably needed for the circuitry. It's probably around 5%. I put a 20% in there, pretty sure of that. But we'll see how it plays. We did have one trace that was bad, surprisingly, only one. But maybe that's all that was needed to throw the test equipment off and not stay turned on. Anyways, I'm going to go ahead and plug it in, and we'll see if we have a functioning set again. And if it functions, we'll finish buttoning it back up and run a few tests. Okay, you are seeing this the exact same time as me. And it sounds like we still have an issue. I hear a relay clicking on, but not staying. Seems to stay that time. Let's try selecting. Right. Yeah, I'm not hearing anything, but I can actually run through my selection now. Over to it. Receive. Okay. Well, we're staying on, but not hearing anything. And when I'm in monitor send or monitor receive, I should hear something coming out of the speaker. But we are staying on. That relay issue, it might have, or whatever's clicking over, I assume it's the relay, might still be bad. But we can definitely go between send and receive, just like that. And see, can I change the level? -100, enter. Frequency, let's do 1000, enter. Yeah, just no audio. Well, let me get a test cable and plug it in. We are in 4-wire. Maybe I just messed up something with the speaker, putting it back together. Hopefully it's still generating a tone, but we can test that out. I'm not seeing any measurement. Turn it off one more time, turn it back on. Froze up. like it wants to work, but it's just not working. And could it be that it's just not generating a tone? Tell you what, I'll turn on my other transmission test set, and we will see if we can get received through it at least. Put it to monitor SIN. We'll go all the way over to ABS. Let me grab my other cable. Yeah, I have my other transmission test set for -10 and 1004 hertz. And SIN is actually working, so the issue is going to be on the transmit side. Actually, I can turn the filter off and we can watch that in real time. Okay, filter is off. And I'll change the level. And you can see it decreasing here. -12 and 12.1. -13, 13.2. -16, 16.1. Let's go the other way. -9, 9.2. -6 and 6.2. -0 and 0.2. That's screaming. Alright. Let's see, can we do a noise measurement? Yeah. Alright, so those are working. The issue now seems to be primarily stemming on the transmit side. And transmit side alone. Let's bump down our power level back to -10. And let's step down our frequency. See if we get a frequency change on here too. We'll do it by factors of 10. 994, 994, 984, 974, 964. Alright, we'll just keep going down. 814. 604. 434, 300, 194, 74. Let's step it up. 2004, 2004. And our amplitude didn't change too much while going through that frequency range. If it had changed at all, I wasn't paying too much particular attention to that, but I didn't see it move around. If it did. So at least it's staying on now. We just gotta figure out what's going on with transmit. The transmit section is not working whatsoever. Alright, so we gotta figure out the transmit section, but now we are getting power. I think it's a relay or something that's sticking or not fully closing. I need to dig more into this and see where we can go from there. That all being said, I think this video is long enough. I'm going to have to really dig into this test set, hopefully find a schematic, but we are getting it to turn on now. And we are definitely getting receive, and as far as I can tell, the receive measurements are pretty close to where they should be. So if you'd like to see me finish working on this personal transmission test set to get the transmit portion working and fully operational, let me know in the comments section. Regardless, thank you for watching this video and staying with me thus far. I'm pretty happy with where we've gotten to. I was super hoping this entire AM-48 would work just with that small repair, but it looks like I have more things to look at. That being said, please consider subscribing to this channel if you haven't done so already. Give this video a thumbs up, leave me comments, all those silly little dibbly-doo type stuff. If you're looking for an item to get for repair, please, you can check out my Google site. The link is in every video I provide, as well as the description on my main page on YouTube, the About section. Reach out to me through that website. It tells you how to get in contact with me and what is required in order to get an item that you have repaired. All that being said, thank you for watching, take care, and goodbye.
Bark.